Hi, I'm David Penn, a research analyst with Finovate. Thank you for joining us for the Finovate FinTech Halftime Review. Today, we feature Jeff Freed. He's Director of Product Management for InterSystems, who will lead a discussion titled A Practical Path to Machine Learning Success in Financial Services. We've got quite a bit to cover today, so let's get started. Jeff, the floor is yours.
Well, thank you very much, David. It's delightful to join you. And I thought what I would do is share some prepared material that is about the way that I see machine learning being adopted in financial services, where the pitfalls are, and how you in the audience can avoid those potholes and really pragmatically get to success. Uh, and then, David, it's always good to talk to you, so maybe we can spend some time on trends and things after that.
Fantastic.
So I think you are able to see my screen, and um, just as a little bit of a background on myself and InterSystems, I'm a general purpose nerd. I've been working in software for a long time at a variety of companies, including Microsoft and some startups you'll never have heard of. InterSystems is a vendor and a provider of some amazing software and solutions to make use of your data. And we work with 8 of the 10 top capital market firms, many folks in financial services and elsewhere. The watchword that I'm sure you'll have heard is that in the economy in general, data is the new oil. That the every one of our customers is deeply engaged in making their data better and better and making use of it for competitive advantage. Uh, and much like fossil fuels drove a huge revolution for a century or more in our economy, the same thing is happening with the data economy and with digital transformation in the large. Machine learning is also based on this fuel. And machine learning, if you will, is an engine that runs on this data. It's part of a whole spectrum of analytics. And you can view this as independent efforts or independent tools, or you can view it as I've pictured it here as a sort of evolution from building up a set of analytics around description. And that's typically transactional reports, systems that you have been doing for decades in your organization with known data, known questions done regularly, and they are incredibly valuable. They're the lifeblood of every operational shop. But there's also a set of things that are more diagnostic, right? Okay, I can see what happened. Why did it happen? How do I fix it? If things are going well, how do I make them better? If things are going badly, how do I get to the root cause? And at a very broad picture, I like to say from geosynchronous orbit, that's really what BI tools are about. The ability for a data analyst to get into things, to explore the data, to explore the situation, and be more diagnostic. Machine learning brings you to a whole new stage of this maturity, something that's predictive. So um, this graphic, which is I borrowed from our partner Data Robot, hence the logo, really talks about that as a circle within that to look for opportunities to do prediction, do modeling and deployment of those models in order to predict what might happen and then really get business benefit and adoption out of that. So um, prediction is a whole new stage, very exciting. And then prescription is the next stage. If I know what's going to happen, what do I do about it? So it's analogous to the difference between description and diagnostic. So I look at analytics as this entire spectrum, and at the journey of certainly the customers that I work with as being on this spectrum, who never stop doing transactional reports. And dashboards and reports have different purposes, but you add to it to get more predictive. Now, machine learning as a subset of AI, if you will, is everywhere. You can't, unless you live under a rock, and even with a pandemic, you're inundated by messages about machine learning and success stories and recipes and hype, as well as reality. About 2 months ago, Time put out a cover page around this as really revolutionizing all of humankind. And Gartner did a survey, a forecast business value for next year overall as a 3.9 trillion with a T number across all industries. Of that, about 200 billion is in financial services, actually in banking and securities. That's a huge number. It's an incredible value from machine learning, but it is not proportional to other industries. Other industries I work a lot with healthcare, for example, and that number is much more like 1.2 trillion value in healthcare. Financial services is not getting its share of this pie in value creation. So it's lagging other industries, which is sort of ironic given how quantitative financial services is and how strong the base of traditional BI and reporting is. And the question is why? It's not a lack of applications. I see every day valuable machine learning applications in financial services. And I've picked a list of 15 just as an example. Many of you are already doing some of these, but they range from automated trading and things that are really specific to financial services to enhanced customer services, better targeting, uh, digital assistants for that, which are very horizontal. There's plenty of applications in financial services for machine learning. And every single one of these has dozens of success stories to it. So this is not the reason that financial services is lagging when it comes to machine learning success. After scratching my head, which is why the hair is all gone, and really looking at like this, what's going on here? If I fast forward to the bottom line, it's that this is hard, right? It's gotten easier and easier to build models once you have data. You hear a lot about citizen data scientists or machine learning for, even my sister can do machine learning now. My sister is a marvelous person, but she's not super techy. She's a teacher. The issue is that really building models is difficult. Building effective models, cited by enterprises as a really problematic thing, by an overwhelming number of enterprises, 96%. And once you've got things built, getting it into production so you can get value out of it is another huge struggle. 9 out of 10 folks are having problems with that. And once you've got it deployed, this is an organic thing, right? The models are based upon the data. The data is changing all the time. So you need to monitor it in a different way than many of your traditional applications. And almost nobody does that, like 1%. So we have a path with a huge potential amount of value, lots of applications, but a big tree in the middle of the road. And really what I want to do in this talk is to help you guys in the audience from wherever you are in that path with some tips about how to bring out the chainsaw and open up the path. This adoption challenge, if we go a little bit deeper in terms of what's in the way for the customers that I work with. There's a big one, which is a skills shortage. Getting skilled data scientists or growing skilled data scientists is a challenge. Even as the technology is getting easier and more self-service, this is still the hottest job title in the probably in the whole economy. And effective data scientist is not just like a developer. They need to know, be very quantitative, and also have good instincts about the business. Those folks that aren't data scientists complain about the amount of time they spend data wrangling. There's various surveys of this. Typically, it is 80% or more of data scientists' time is spent collecting, aggregating, normalizing, transforming data before they can really get started on what they learned in school. And I joke that data scientists spend 90% of their time data wrangling and the other 10% complaining about data wrangling. It's a big issue, which is intrinsic to the fact that data is spread out all over the place and all data is dirty. And then deploying things, I showed this statistic about 9 out of 10 enterprises have difficulty getting to deployment. The other half of that stat is only half of people that build models actually get to deployment successfully at all. It's not just that it's hard, it's often that it fails. So this is these are the top challenges. And one aspect that I find useful for people is just a mentality shift. If you can understand what machine learning is about at a basic level, it will help you in terms of your journey, in terms of your resourcing, and in terms of how you grow people. And often machine learning presents this way because it's all mathematics. You know, my graduate degrees are in applied math, and the algorithms behind machine learning have been around for 25 years. It's not new. And understanding them is very deep and very interesting mathematically. But this is scary, and it's actually unnecessary to know these days when it comes to really understanding how to approach machine learning. I find it sort of a little bit easier for many people, especially those that are in the positions of managing a project and not necessarily doing the hands-on data science, to think about the difference with traditional programming at again, geosynchronous orbit. We all learned about software from the standpoint of algorithms, where you write a program, you feed it data, and you get an output. Machine learning is a little bit the opposite. You take an output and fresh data, that is that input, and you feed it to the computer, and it produces an algorithm. The output is usually called the training set, right? And there's a variety of ways of getting the training set. There's a whole industry of people who hand mark data to provide training for machine learning. But often the best training sets are from your production systems, from things that you're currently doing with smart people. And the data is what it's all about. So both the data and the output are themselves data from your data program. And what's happening in the computer to generate the program is that there's a family of algorithms that apply to different kinds of problems, and the computer is able to pick the best kind of algorithm and then change the parameters. So you'll hear about things like random forest. That is a set of classifiers used in tandem to establish, what is this? It's used in many, many problems, and typically with a random forest family of algorithms, you're picking parameters recursively. Or you'll have heard about neural nets, or what's called deep learning, which is also the same thing. Yes, that's an algorithm, but really it's a very general class of things. And until you pick how many layers of the neural net you need and what the parameters are for each, you don't actually have something that will make predictions. So that's really what the training set does. And the machine learning process, which is taking data, both, if you will, input and output data, to generate a model, which is this program, has a variety of steps. This is really showing a 7-step process, which for some reason in the literature, 7 seems to be a magic number. It starts with picking the right problems. And we'll talk a little bit more about that. The data preparation, feature engineering, and feature selection are all data wrangling. And if you're not familiar with feature engineering, what's an example? A classic example is to take a variable which is a categorical and turn it into binaries, what's called one-hot encoding. You have eye color, and maybe you have blue, brown, green, or red eyes, and it's better for the class of machine learning algorithms to turn it into 4 different binary inputs. Has blue eyes, has brown eyes, has green eyes, as 3 separate variables. So that's a simple example of feature engineering. And then feature selection is picking out which are the important input variables that are going to matter. As the number of variables goes up, that becomes harder. And there's a whole field I'll talk about in a minute, which is applying machine learning to that feature selection. The model training step is really where the algorithms come in. So only really a 7th of this is what people learn as data scientists. Addressing the target problems is really about good business savvy and matching problems that you have and data you have, and finding low-hanging fruit. And then this deployment in ML apps we already talked about is a problem. There's a organization called BI Intelligence that I like a lot, and they have an example here, which is a scatter chart, which I recommend if you haven't done. Every organization can do this. You have more than one problem, which would be a good problem to apply predictions to. Where do you start? Well, take your best guess at what are the problems that you have, which things are going to be the most return, the most buck, if you will, and then how hard is it going to be to do? And you're looking for the best bang for the buck. So you typically, and all business consultants do this as part of every, you know, every consulting arrangement. You make a scatter chart of opportunities, you pick out what works, you take typically highest bang for the buck problem, modified by whatever political constraints you might have in your organization. You do it, you build muscle, you do the next one. You see build success, and you don't do it all at once. And that's the way you build up a practice in machine learning, and that's the way you build success, sort of one problem at a time. A classic example that is a good starting place for a lot of organizations is fraud detection. And there's many flavors of fraud detection. But to give you a sense of if you're looking for different kinds of algorithms, a binary classifier would take a particular transaction and say, yes or no, this is likely to be fraud. That would be like a credit card transaction. Is David trying to, buy an expensive trip, or, the fact that this came from Russia at 3 a.m. when he's typically asleep, is it likely to be a fraud? A multi-class kind of algorithm would be something you'd use for risk level, low, medium, high. If you're doing, for example, loan origination. Numeric regression would be what is the most likely leakage due to fraud for a customer. Let's say you're in a wholesale business, or people do this a lot for, we work in the supply chain area, where you sort of have to factor in a certain amount of leakage or fraud or spoilage or theft across the supply chain. Time series algorithms are often used to predict things over time and take in seasonality, et cetera. And then the predicting when this particular customer is likely to have a fraudulent transaction to get more proactive would be an example that you'd use a binary thing. So this is mostly to give you a sense that depending upon the question you're asking, you'll pick a different algorithm, even with the same data. And fraud prediction is a good place for many people to start because the demand is going up, and you see fraud problems in a whole variety of areas. I've done a lot with anti-money laundering, for example, which you would think is a solved problem, but you can still get significant benefit out of doing this type of prediction, even if you've been using linear regression for a while at it. There's a development in machine learning called AutoML that's been going on for about 5 years. And you'll now see most of the major machine learning vendors have some form of AutoML. What is that? It's applying machine learning to machine learning. So you're taking some of the things like the feature engineering, where you're taking, remember, the eye color and blowing it out to binaries. Why does a person need to do that if you know an algorithm needs binary input, just have the computer do it. And most of these do what is called ensemble learning. You take the same problem, you throw lots of different kinds of machine learning algorithms at it, and you see which one gives you the best predictions. Often it's a combination of several different algorithms. in working together. That's why it's called ensemble learning. And that makes the choice of which algorithm to use for a problem automatic. And then the data scientist is not out of work. They can just focus on the nuances, the performance, the tuning, and not do rote things. So AutoML is automating a lot of the tasks that data scientists have done in the middle of this process. This is amazing stuff. It doesn't take away from the need for data preparation. You still have the garbage in, garbage out problem. And it doesn't solve the deployment and ML ops thing, but it does make the middle of the cycle much, much simpler. We use this at InterSystems quite extensively. AutoML using machine learning to learn ML. We actually, in our integrated ML offering, we actually provide 3 elements. We provide one that is based on pure open source. You'll see this in XGBoost or scikit-learn. We have partnerships with H2O, which is a AutoML engine, and with DataRobot. It's also one of those 2 companies are the 2 premier AutoML providers. And worked a lot with DataRobot to provide services for customers. But there's another way of looking at what it looks like from a data scientist standpoint is essentially a recipe with an easy button. It's called autopilot that runs through these steps and gives you a set of prediction distributions and what's called a ROC curve. The way you think about this is what accuracy am I going to get, and different kinds of problems. Let's think about a binary prediction, true or false. In some kinds of things, you want as few false positives as possible, right? In some kinds of things, you care more about false negatives. So depending upon the business context, you want to be at different points in this curve because the cost of getting it wrong one way or the other is different. And then the way you can think about this probability density is you're really looking at the shape of how different predictions happen with different kinds of data and what happens if you change thresholds, because you'll be doing watching that as you train things. But this is particularly useful in what's called ML ops, because the data will drift over time. And there'll be a point when the data drifts enough that your model is no longer effective. And that's the point at which it's time to retrain. So it gives you a flavor of taking this 7-step process, making it simpler with AutoML. And then we've actually taken it a step further by simplifying the data wrangling process with a capability we call integrated ML. And the idea there is to move the machine learning as close to the data as possible. One of the issues with deployment is separate systems. You go train on things in the lab with a set of tools that only data scientists know, and then you put it into production in a completely different set of tools that only operations people know. And the data is different, and then you're spending your time troubleshooting what's different between environments, and it slows everything down. The other aspect of this is we've learned that a lot of these predictions and matching the machine learning algorithms to the problem are just the same thing that developers do as they develop applications today. Right? They feel weird because it's a whole different lingo and because it's not deterministic, it's probabilistic. But the people who are developing applications already have a sense of the problem domain, they already know the data, and therefore making machine learning easy to tap into for a developer has been a focus for InterSystems. And so we've introduced a thing called integrated ML, where you use SQL. And if you know SQL, you can do machine learning by using these predicates. You create a model, and that's essentially doing an autopilot kind of AutoML model. Train the model, and it feeds data, whatever data you have at hand through SQL, and then use a predict predicate anywhere you would use anything in SQL. So you can use materialized views, you can use different selections, joins. Um, Makes it very familiar to people that know SQL. And turn a lot of the data wrangling is done in SQL anyway. That's where you're bringing data in, you're looking at the shape of it. So we're essentially bringing things into an integrated environment to simplify, not eliminate data wrangling, but also simplify deployment. And these work in combination. So a typical environment with integrated machine learning will have a SQL developer working on data that may come from lots of places, working in SQL using these keywords that I mentioned. I'm showing here a healthcare example. We work a lot with healthcare companies as well, where you're creating a model to predict whether uh, a patient is going to have a high amount of pain and be readmitted based upon a history of other patients. And then you're using the same thing that I showed you from the data robot console in order to watch the model over time and in order to bias the model. And the data scientists can spend their time on these very interesting and still very unautomated elements of what happens if I tweak it this way, what am I missing? There's also a whole area of what's called explainability and transparency of these models, which is worth another talk. But it's built into many of these tools, and it's important. It's also important to have data scientists that know how to explain what things are doing, especially from a regulatory standpoint.
Mm-hmm.
We have a customer, Well and Capital, that has done this with Data Robot, one of our partners, in exactly this setup. Data Robot provides some great customer-facing data scientists as well as great machine learning and ML ops technology, and used that for loan underwriting. Right, both. It's another good place to start because it's often making binary decisions, yes, no, um, and it's an area where reducing variability gets you more efficiency. It turns out that subjectively, uh, loan underwriters think they're much more consistent than they really are. And inconsistency equates to inefficiency and also risk. So there's a good video here that you can look at from Well and Capital about their experience. I think this is a great example of a good place to get started. So I've given you a sense of financial services being underrepresented in terms of the predicted amount of value from machine learning next year, and that the real obstacles to that are about the difficulty building models, the difficulty deploying models, the difficulty monitoring models, and that the way you can really address that is, number one, to pick the right problems. Use a scatter chart. Don't try to do it all at once. Number two, look for tool sets that fit your people, and leveraging people like the existing SQL developers and data analysts, not instead of data scientists, but to address the skill shortage, so you can use the data scientists you have more efficiently. And then look for things like integrated ML to simplify this 7-step complex process into fewer things, so you can focus on picking the right problems and getting things to deployment and run a deployment. I mentioned that I work with a lot of financial services organizations, but also in healthcare, supply chain, government. This pattern and what I've just said is not unique to financial services. And the challenges that I see as big trends are that there's a much more visible need to be resilient because stuff happens, and we all feel that as we come out of this pandemic, that using predictions, there's a higher demand on predictions because business managers want to be able to see around corners and navigate these disruptions more effectively. They're happening more frequently. And the demand for data is just going up. So applying machine learning along with modern data management techniques is a big trend that I see, whether you call it data fabrics or data virtualization. There's a lot of areas in this, but machine learning is not an island. It's connected very closely with your data management strategy. And the data as the fuel for machine learning applies everywhere. This is a paper from last month's Chi conference about the bias towards focusing on the model, not the data, causing issues in machine learning. So if you are focused on having solid data management, you are ahead of most machine learning shops because you're focused on the foundation. There are some differences in financial services that are really, really interesting. One is that there's many more extremes in terms of volatility. And that's literal in terms of the volatility in the market that we've all seen in the last few months, but also in the variety of types of data and the sheer velocity. Not every industry has as big of a appetite for real-time predictions, but certainly, I mentioned credit card fraud. Wouldn't you like to know now, before the transaction's approved, that this is likely fraudulent, instead of knowing tomorrow? So there's a much bigger emphasis in financial services than many industries on this real-timeness. The other interesting one is that this is often a competitive game. And you can think of this in terms of automated trading. Let's say you've used machine learning or any other kind of advanced analytics to do automated trading, and you're winning. Well, your competitors are going to pick up on that awfully quickly. So they're going to learn and they're going to change their algorithms, which means that your algorithms are going to be out of date. And that's called in the literature something that's non-stationary. It doesn't stand still. You can't do machine learning on last year's data and just run it for a while, because as you know, the dynamics of the system change very frequently. And we see this more in financial services than many other industries because of the competitive nature of the game. So let me wrap up just as observations. I've taken you through the top obstacles that I see working with financial services customers and some ways to avoid them. Pick the right problems up front and iterate. Look at how you can incorporate AutoML and integrated ML into your practices. Focus on the data management continually, as you do today. What I also hear is more and more of this term of either agility or resilience, the sort of flip sides of things. The way I think about it is IT agility is how fast you can move, and resiliency is how quickly you can turn. But that really, I think, has three key ingredients that I hear from my customers. The one is flexible technology. Another is healthy data, and that's actually that's now one of the mantras of InterSystems is healthy data. So you hear us talking about that a lot. And the third is responsive partners. You're not in alone. This is a hard problem. Um, so you can get help. And the basic of this talk then is, start by picking the right problems. Do yourself a scatter chart. Pick Goldilocks problems. Don't try to get like a huge win right out of the gate. Simplify data ingestion and integration because your data is spread out all over the place. Integrate NML into the application content because it's really matching the business problem to the data, and you already have people that do that. And then things don't stop when you go live. In fact, often in traditional software development, you put your architects on the problem early on. They do the design, then patterns, and then they go work on something else. And then it's routine from there to go through QA. And for machine learning based things, the action happens when the thing goes live, because that's when you actually hit data changing and you're actually making predictions and you're seeing things. So that's when you want your best architects available. So it'll change your staffing patterns as well. And then just as a slight advertisement, I believe the world I live in is one of our InterSystems Iris data platform. And what we've done is take a high performance database that is heavily used for what's called transactional analytic or translytic things, and brought in the piece parts so that the interoperability is built in next to the data and the machine learning is built in next to the data. It's been delightful. I hope this part has been useful to you guys, and certainly any questions or comments or any way I can help, here's how you reach me. So, David, is this hopefully works well for the Finovate audience, and I'm love to hear your perspective on this because you live in this world every day.
Yes, and I first want to thank you for the presentation. I forgive me for furiously taking notes during it because there was so much that you shared, and in particular toward the end of the presentation, one thing that I thought was really helpful that was actually going to be the kernel of my first question really had to do with sort of parsing out that financial services problem. I thought you did a fantastic job of sort of articulating the general problem, the general challenge of implementing machine learning. And it was in that sort of latter third that we really got to see some of the things that made it particularly, finding the skills is going to be a challenge for everybody. Data wrangling is challenging for everybody. But then really getting to see what are the specific aspects of financial services that make it different from some of these other industries in terms of understanding why it's not been able to take its share, I think was very, very helpful. I think people maybe reading it are starting to say, well, why can't we do these things? Why can't we do these things? And there are certain requirements. You mentioned the real time, for example, nature of some of the information as being one of the major hurdles that financial services companies have to deal with. And I thought that was especially helpful.
Yeah, I think also I find that financial services companies have some advantages.
Mm,
The data quality on average is better because I mean, as I said, all data is dirty, and you'll be wrestling with data suitability and quality forever. But
mhm,
many more financial services organizations have a healthy data quality initiative.
mm,
And if you are working on operational data, it's clean because it has to be. This is what you're
right.
doing trades and financial things on. And many financial services organizations have a much more sophisticated and realistic viewpoint of risk and probability.
Mm, mhm,
Machine learning freaks many developers out because it's it's not it's making predictions that might be wrong, and it's not deterministic. If you're running a
mm,
Q automated testing, for example, for QA, you're used to, okay, here's the answers. You have to change the way you do automated QA for machine learning based things
mhm,
because you'll always have some percentage of wrong answers.
right.
Well, financial services firms are that they're used to thinking about probability and risk and this as a distribution, not as a black and white thing.
Mhm. Absolutely. It reminds me of a conversation I had relatively recently talking about the ability of banks to deal with climate change challenges. And one of the points that the person made was it might seem very difficult for something for a bank to deal with, but as you said, they deal with risk and probability as a nature of being. And that while this is a bit different, in terms of the sort of approaches, the mentality, and things like that that can be put to task are very much the same.
Yeah, I'd love to listen to that if you can shoot me over the thing you read. Um, I It bugs me to see that financial services firms are not getting their fair share of the the value pie out of machine learning. It's now very accessible technology, not easy,
Hmm.
but available, and most firms have some initiative, but it's not going as fast as in comparable industries, and I think people are struggling with it, and that's why I really wanted to get this message out.
Do you think that there's, I'm thinking about, I mean, one of the things that's amazing, and you do a good job of sort of the timeline, the AutoML I've heard of, I know, I suspect a lot of our fans had, integrated ML I hadn't heard of. And it's just fascinating to see how so many of the pain points are being increasingly taken up by technology and different sorts of tools and things like that. And I'm just thinking about that in terms of financial services being able to use this in, like you said, higher ROI, sort of easy to locate things like fraud prevention, automated trading, where you want speed, where you want some really definitive and need definitive answers. I'm wondering, do you think that will be a particular application of ML that might not be as high on the ROI spectrum, but might have a similar sort of impact to the way that financial services companies see themselves that might help accelerate the adoption and really trying to get more things accomplished in the space?
That's a really good question, David. I think picking something with people in the loop
Yeah.
that lets you learn is one of my favorite patterns. And if what you're saying is what's a good starter thing that is maybe lower ROI but easier to do and lower risk, I'd say something like customer facing alerts
Okay.
so that you can provide value to your customers by giving them more insight and letting
Mhm.
them filter things. Uh, and then you just have to make sure you don't flood them with noise.
Right. Right.
I've seen people in wealth management do that, just like traditionally you've been a source of news feeds to your high wealth customers.
Mhm.
Now you can provide some predictions that are more insight and they're people in the loop. So you're not, it's less risky.
Yeah. And just thinking about it, the ways that, I mean, we think of them as alerts, and I can imagine as this develops that it becomes less of a feeling of an alert and more of a feeling of a compendium of a news service. I mean, we think of all the different places we get our information. I can see the whole relationship to people and their banks, where they get their information, the kind of information that's really relevant to them, really starting to shift over time as the concept of this alert and engagement maybe starts to shift.
Yeah, I don't claim I have my finger on the pulse of America or that I'm a typical customer, but personally, I my financial advisor sends me distribution plots. Or what he sends me is very quantitative, and I encourage that. Uh, it's it's not Boolean, buy this, sell that. It's like, here's the shape of the market today, and it's I find as he's gotten more and more sophisticated, I like it more and more.
Fantastic, fantastic. Unfortunately, we're running out of time. We're coming up to the end of our session. We could be in this conversation for quite some time as I'm just going over some of the things that you shared with us. Very, very good stuff. And again, I really appreciate the way that you really honed in on the pain points with ML, and specifically some of the areas that financial services are challenged and have advantages, and some of the things, that sort of three-step program that they can handle it with. And I want to encourage folks to take advantage of Jeff's contact information there, email, LinkedIn, Twitter down there. Definitely go ahead and take a look at those. Reach out to Jeff with any questions, comments you might have. I just thought we've got maybe about 45 seconds left. If there was any last takeaway that you wanted to leave with folks.
Well, two things. I wanted to also emphasize and mention that InterSystems, as a vendor, we have a machine learning site on our website. So go to intersystems.com. We have both business and technical information about machine learning, as well as a lot about data management in general, because that's what we do day in, day out. And I want to reemphasize that this is, of course, a journey. We're going to be, this machine learning as an engine and data as the fuel is the next century. So wherever you are in that journey, this is going to be a great ride.
Absolutely. Thank you very much, Jeff. We had a fantastic time talking with you. Look forward to speaking with you again soon.
You too.